What's going on, everyone? My name is Johnny Bandon and I'm your CCNA instructor for this CCNA video series. And in this video, we're going to go over our NTP lab. So again, NTP being kind of the simple protocol, we're going to try to make it as interesting as we can in our EVE-NG environment. So let's kind of go over what we have going on in our environment here. So let me just minimize this. Okay, so we just have two iOS devices this lab for this lab. So we have R1, R2, and R1 is going to be a server and a client. So it is going to be reaching out to the internet to get its timing synchronization, and then it's going to act as a server for R2 over here, which is going to be purely just an NTP client. So again, we have our instructions over here on the right, but of course, for any of our viewers, we also have our GitLab. Let me clear that screen off, where we do have the lab instructions under our CCNA video course, and we do have the baselines here. For our paid viewers, these routers are already going to be pre-configured with the IP addressing and like the one static route you need to reach out to the internet using this network management cloud. So you don't have to worry about those steps. For our non-paid viewers, we have baselines available in our GitLab at our root directory here. And then we also have EVE-NG how-to videos to see how to build this kind of lab yourself. And this lab is extremely easy to build because it's just two viral routers. Okay, so step 1, 2, 3, verify all IP addressing and routing. So let's go ahead and do this. I've already turned on these routers because if I'm using any other viral CSR router, I like to start them before I start the lab because it takes a little bit. So we have R1 here, R2. And because of that baseline we put in there, they're going to have a username and password. And let me just expand this for everyone so make that picture a little bit more clear. All right. So now we're just going to verify IP addressing. So let's go ahead and do that. So on R1, we should just have only 2 IP addresses. Include up because we love using regular expression, right? So 192.168.1.66 is going to be the IP address going out towards my network management cloud. Because remember, in previous videos, I've explained this before, but what this management cloud does is essentially give access to my subnet here. I'm on an ESXi server, EVE-NG is running as a virtual machine, and this is giving access to that subnet for any device in here to connect to. So what we got to do is just assign an IP address within that /24 range, and if you're doing this at home, it's whatever range you gave your home network or your ESXi server. Mine is just the basic one that is used, any home network. So we just got to give it an IP address within that subnet. And then as far as routing goes, we just got to put in one show IP run. It's just show run. We just got to put in one default route out towards that network management cloud. You can either do the interface. I did the default gateway. Awesome. And then of course we just have our IP addressing between R1 and R2. So let's just go over to R2 and make sure that we have an IP address configured to R1. And yes, we do. Let's just do a quick ping. All right, we're good to go. That definitely would have messed this up. So let's now jump into the NTP configuration. So step 4 is going to be configure R1 to be an NTP client from a public NTP server. All right, so I'm going to show you guys how to get an NTP public server IP address from the internet. So I kind of already have it pulled up here. I just went to the NIST website, but it really is this simple. If you just type in public NTP server, there's so many out there. So we have Google Developers free public NTP. I just did the NIST one, and I came down here and just got a pure NTP IP address. You see this is all services. I don't know what other services these provide, but I just need an NTP server, and that's what I'm going to do. So I'm going to copy this IP address. I'm going to go back to my EVE-NG topology. I'm going to go back to our CLI here. And in R1, first thing I'm going to do is just run a quick ping test, right? We got to make sure we can reach this, and we're good to go. And now the one command to make this a client is NTP server, and then that IP address. It's literally that easy. So that's going to be step 4. Configure R1 to be an NTP client from a public NTP server. So let's look at our clock here. Okay, it looks like we may be synchronized, but let's go ahead and verify that. So how do we verify our synchronizations? It's gonna be show NTP associations. As you can see here, we have, let's see, like probably like a mechanical name here for that NTP server, then the actual IP address. And the key thing we're looking at here is to make sure we have that asterisk right there. That means that is a system peer. So we are synchronized to that NTP server. We just did one more show command. Let's do a show NTP status. All right, it says clock is unsynchronized. Let's just leave this up to an even G-ism, right? I was telling kind of in the past video, sometimes NTP acts weird of even G. I don't know why, but that clock is synced up to the NTP server, and this was a real-world device. I don't think we'd have any issues. Okay. So let's move on. So step 5, configure R1 to also be an NTP server for R2. So let's go ahead and do that. So with that command, check it out how easy it is. It's NTP master. And you know what? Let's just give this a stratum level of 5. Let's go crazy, right? And then step 6, configure NTP authentication on R1. So now we're going to go through our authentication commands. So first command I'm going to do is NTP authenticate. And then we're going to do NTP authentication. We're going to do key 1. Look at all those key numbers we can have though. That's a lot. And then we're going to choose our hashing, which is only MD5. They don't do SHA or anything a little bit better. Old school, right? And then we're going to do our actual password, our authentication key, which is Cisco. And you're going to notice like the authentication key is used, the terminology used a lot when you're just setting a password in Cisco. So I always try to break that down because when I first started, I was like, authentication key, what does that mean? It's just a password. It's just a pre-shared key like you do on your Wi-Fi, or a password that you configure anywhere else. And then we have to do this NTP trusted key command, and we're going to choose our key number of 1. And that's going to be it for R1. Now, when we go over to R2 and we configure NTP, what we're going to do is essentially the same commands. We're going to do our 2 authentication commands, key 1, MD5. Make sure that matches the authentication key or that password. We're going to do NTP trusted key as well, 1. And then for our NTP server command, we're going to put the IP address of R1 that we can reach. And then it's going to be key 1. And that's going to be it for configuring this client with the authentication. So why didn't we just have R2 also point to that public NTP server? Well, we have not configured IP reachability from R2 to the internet. And maybe we're in an environment where we don't want to. Maybe we're in that closed off sandbox environment, or maybe R2 should be in that closed off environment where we don't want internet connection. And there are scenarios where you may be in that situation on the network you're working on. If you work in government or really in a private sector with really harsh restrictions on their IP. If you ever worked at like something like DARPA, you know, there's going to be sometimes separated and segmented networks that are completely separate from the public internet that maybe you need to synchronize NTP with all those network devices within that network. So that's why we don't reach out to a public server here. Okay, and then of course, we just need to verify associations. So again, it's gonna say, it's gonna need that asterisk there, you know, but let's just go ahead and do show clock. Do show clock. We have the same timing on both these devices. So let's go ahead and just put these side by side. What I'm going to do is send commands to all sessions and then come down here, do show clock. All right, so it looks like we're a little unsynchronized here, and I'm not going to spend time troubleshooting this for you guys. And here's the reason. I went through this lab a lot before I recorded this video. I went through all the Cisco best practice. And in my in-person courses, this happened to me a lot where it may just be an even G thing. And maybe if this video goes viral, someone can tell me what I'm doing wrong. But we're just following the NTP steps for configuration. And if this is saying that it's unsynchronized, even though there is only one command you need for NTP synchronization. It's NTP server command with an IP, then that's okay. You know, maybe this NIST server, maybe we need to implement some sort of encryption or other authentication I'm not aware of. And that could be the case. But as far as like R1 and R2 go, so if we show NTP status on R2, it says it's unsynchronized, but there should be really no reason. You know, we configured NTP exactly how we're supposed to. So it's just kind of, you know, I'm moving on from this because I don't want to spend too much time troubleshooting something that maybe it's not our fault this isn't syncing up. It could just be something with these emulated devices. So with that being said, that's going to pretty much do it for our lab. It wants us to do a manual setting of the clock too. We can definitely do that. And before we go, I just want to show you a quick packet capture out to the internet and then a packet capture between G01. And important things for you guys going to the CCNA exam, right? The NTP commands. NTP master. Remember, this sets an NTP server on Cisco iOS. And then NTP client or NTP server command sets you up as an NTP client. It's very important that you remember those distinctions because it may be something that you can be tested on. I know a lot of my students say that was important, like understand the difference between these two commands because let's be honest, they can be a little confusing. Again, if you just don't know what they mean or what they're doing. So let's go to our packet captures here, something I always like to do in every lab, a quick packet capture. So if we look at our NTP request, let's go ahead and stop that here. Our NTP request from R1 to that public NTP server. That's what I'm saying, that there may be like something that an extra step I'm not configuring with this public NTP server with this WireGuard protocol. I don't have WireGuard configured, and I'm assuming it may be wanting some encryption for this public NTP server. And that could very well be the case. You know, when I looked in here, I didn't see anything that said that. But just to be on the safe side, you know, let's go ahead and just try to look at a Google public NTP server. So let's see. Let's see if it'll give us a quick IP address here. See, time.google.com. So let's try it this way, huh? Maybe give us some extra troubleshooting for an easy lab. Maybe we'll do some learning. So let's go ahead and clear our NTP configuration for R1. No NTP. And now let's do something like this. So let's go ahead and set a name server. So we want to do DNS lookups using Google's DNS. We're going to go IP domain lookup. Okay. And then let's make sure that we can still ping 8.8.8. Okay, move this out of the way. All right, we still can. So I'm going to come down here. This is just a quick way to do a little, see if we can do DNS lookups. All right, we are good to go there. Reset that connection. And let's go ahead and configure NTP server. Not that. Let's go back and get our public Google server. Okay. So it said we got an OK command here. Let's go ahead and try to ping that actually. Ping time.google.com. If we can reach it, it looks like that's the IP address for it. Now let's see if we have something else different for show NTP associations. Okay. From there, it looks like we're good, right? So let's go ahead and do show NTP status. Still says unsynchronized. And this is kind of what I'm saying, right? I mean, this should be as simple as it is. We can just do a quick packet capture again. Maybe, you know, we can see something on the wire that we're not aware of. Maybe they're running WireGuard configuration too. Okay, DNS. Yeah, it looks like they are. And, maybe there is some encryption that I am not following on our iOS that maybe we need to be aware of. Junos. Let's see if it has iOS in here. Oh, Cisco iOS. Yeah, I mean, look, it's just so simple what it's supposed to be. So again, I'm just gonna leave that up to an evangelism, and that's okay. We just need to know how it's configured, and if it's not gonna work in our sandbox environment, that is a-okay. Now our last step, I'm just gonna show you how to manually set the clocks on both routers. So really, I'm just gonna do that from R1. I'm gonna go ahead and clear this NTP configuration, show NTP config, nothing going on. So we set the clock actually from privilege mode instead of global config mode, which also is a little confusing at times. And then we're gonna set the actual time. And then we're gonna do a date. So we'll do 1st March 2023. Boom. Then we can also set the clock time zone if you wanted to. So we can do PST -8. And then that may just change our timing though from the clock we just set. And then we have other commands we can do. We can do calendar valid, meaning, hey, the counter time is authoritative. So we'll go ahead and look at our clock here. So it kind of put us back 8 hours, right? So PST time. So just a couple different ways you can set the clock there. All right. So that's going to be it for this NTP configuration. Show NTP status. Just want to see what it looks like. Again, NTP not running, so we did manual configuration of our clocks. Awesome. So I think it was a good video. We kind of learned a lot about NTP. Kind of showed how to actually set up NTP publicly. That was always one thing that kind of bugged me when I was going through my CCNA training with NTP. Again, this is 8 years ago, so training has gone a lot better. But we would talk about NTP, then we wouldn't actually configure it for like maybe what an enterprise would do. So I'm glad we kind of looking at Google here, just showing us how easy it can be, and that's something you should never be worried about if you have to set it up in a real world environment. Awesome. So that's going to be it for this video. I want to thank everyone for viewing, and stay tuned for our next video.